you can put on, maybe if the experiment is involving maybe moving objects, stretching materials, which can hit your eyes. We can talk of boots. If maybe they are falling objects, you can consider putting on that. We can talk of gloves, yeah, in case maybe you are handling objects, for instance hot objects. You can use using forceps to hold, yeah. So some of you need to know safety precautions in involving different experiments. Student repeated measurements of D and then in different orientation. This was an experiment where a micrometer screw gauge was being used. So the student, the examiner is saying the student repeated different measurement. Explain another technique. So explain another technique the student could use to determine the accurate value. So if you are told additional technique once the measurements have been taken by this type of instrument, so anytime you are using a meter to measure the height accurately, you need to clamp that. You need to say clamp it in position and then use a set square to check whether the ruler is vertical. Then you can be able to take the measurement. And also, if you are taking a measurement, ensure your eye is positioned perpendicularly so that we can be able to avoid the error of parallax. Let me also mention another concept that is key when it comes to Unit 3 is calculations that you are going to be asked. One of the calculations you are going to be asked is mean of a quantity. So meaning you might be given different data and you are supposed to work out the mean, and to do that is the total sum divided by number of data. Yeah, for instance, if you are told maybe you have 2.0 centimeters, 3.1 centimeters and 4.6 centimeters. So this is the data that you are given, and then you are supposed to work out the mean of that. To work out the mean, you are going to say mean is going to be 2.0 plus 3.1 plus 4.6 divided by how many are they? They are 3. So we are going to say this is going to be, if you add all this, you are going, this is going to be, this is 5, you add 4, that is 9.7 over 3 centimeters. So you can now put that in your calculator so that you can be able to get the answer there. So that will be 9.7 divided by 3, that translates to 3.2. You must give your answer correct to the number of significant figures that you have provided here, and that will be 3.2 centimeters, like that. So another question that can arise from here is to calculate percentage uncertainty. Percentage and uncertainty. To calculate percentage uncertainty, what you need to do in this case is first to work out the range of the data that we are given here. The largest value minus the smallest value, that will be 4.6 minus 2.0, and that will be 2.6 centimeters. Then now uncertainty is going to be a half of the range. If you are given a question whereby you are given different set of values, for you to work out uncertainty, it will be a half of the range. So in this case, our uncertainty becomes what? A half times 2.6, and that becomes 1.3. Then percentage now uncertainty will be the uncertainty we have, 1.3, divided by the mean we got. This mean that we have here, you must give it to one significant figure or two significant figures. So this is going to reduce to 0.41%. Your answer should either be one significant figure or two significant figures when you're giving the answer. Now, another type of uncertainty calculation you'll be seeing in your exam, and then you are supposed to calculate the percentage uncertainty. Anytime you are going to do a Unit 3 exam, you'll have a question that has different measurements, more measurements, and you'll have another question that will have a single measurement, and then you are supposed to work out the percentage uncertainty. So whenever you are given this one, you have to find the mean, then find the range, use the range, divide by 2, you get the uncertainty, use that uncertainty, divide by the mean that you got to get the percentage uncertainty for that. But when you will be given a single data value like this, you are going to use the concept of resolution. The resolution of this instrument, we say resolution here, in the least unit, this instrument that was used here can measure, yeah, and this could be a micrometer screw gauge, yeah, because it's in millimeters and it's also in 2 decimal places. So uncertainty in this case is going to be a half times the resolution that we have, and that's going to be a half times 0.01, and this is going to be 0.005 as the absolute uncertainty. Then for us to work out now percentage uncertainty, we are going to say this is going to be equals to the uncertainty we got, and the uncertainty we are getting from a half of the resolution, and the resolution is the least unit of measurement, and this is going to be 0.005 divided by 2.08, the measurement that was provided, times 100, 0.24%. And we have said that anytime you are writing percentage uncertainty, it has to be to 2 significant figures or to 1 significant figure. So make sure you sign against where you have written that you will always write it in 2 significant figure or 1 significant figure. Otherwise, if you don't do that, there will be an international crisis when your paper is being marked. I have a challenge on how to answer questions in this particular concept in Unit 3 Practical Physics. Check in the description. I've added a link where I've done a detailed past paper showing you how you are supposed to answer all the questions. In that particular video, I've really taken you through, I've given answers on how you are supposed to approach each and every questions. So check in the description so that you can be able to see more questions and the more concepts that are tested in this unit and how you are supposed to approach them. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next tutorial.